Hey guys, back from the early television convention. Took a few days off to recuperate, and now I am back on the Zenith. I'm also using the new camera, so this will be the first restoration segment with the new camera. We'll see how it goes. Now, the date for the Vintage Computer Fest Midwest has been set. I think it's the first weekend in September, which means I have a hard deadline now. All those TVs that arrived last fall have to be done by then and ready to ship out. So that is this set, the Dumont, and a bunch of Predictas. The Predictas, I have well underhand. I've started working on a few, and I know how to do a Predicta, and I have spare parts and all that stuff lined up. It's the porthole and the Dumont that are new territory to me, so I'm focusing on those first. Then I'll get back to the Predictas, and also I'm going to be picking up the pace, meaning I'm going to spend less time babbling about testing capacitors and such, and theory of operation. We're just going to get in there and get it done. So I was waffling on what to do about the electrolytics. Simple. I'm going to remove them, use adapter caps. I started on this guy. They're actually easier to get out than I realized. Here's a look at one of them. It's actually marked Zenith. And I'd already ordered up all the parts for this, so I just built one up. Now the only, and actually this works out kind of nice because I can leave the CRT installed, and when I disconnected it and untwisted the twist locks, there was no problem getting it out on the other side. And I can slip this in from the other side and mount it. The only thing is that I'm going to have to drill some holes, but that's not that big a deal. I can drill from this side. So I lined up all the symbols with this, and I'm going to mount it in here. And this one had already been replaced, and the new one they did not really mount very securely, so that should just practically fall right out. That's the most difficult one to get at. And then after this. And the reason I'm focusing on this too, as I was mentioning in the previous segment, work had been done in here. I found one resistor that was completely open, some dubious work, some values in the replacement parts weren't quite right. So I want to focus in on all the power supply stuff. Rebuilt a portion of the horizontal. So I want to finish this area and do a little bit down in here. Now here's another guy that I definitely want to get out of there. It looks like a gigantic mica capacitor, right? It's very likely a paper cap inside of a Bakelite housing. They didn't make mica caps that look like that. They were that large. I think mica mold was the primary culprit in making caps that looked like mica that were not. Those tend to pop. And I want to get these guys up. Basically the large bumblebees, some of which are already split open. Let's just take care of them right off the bat. Then we'll try powering it up. If all goes well, my remaining primary concerns are fixing up the broken lucite, so I can secure the mounting strap that's supposed to go over here, and restringing the fine tuning. If that's all I have to do, we're in great shape. The other big unknown is the flyback. Well, I'm not quite done recapping yet, but here's an update because I decided, for the sake of safety, I didn't want to damage that replaceable CRT, and to gain access to everything, I just went ahead and unmounted it. Took reference photos of how the ion trap magnet was situated and such, and actually it wasn't too hard to get out. The main thing was I had to detach a bracket down below that also holds the switch. There's a tip to not loose screws. I'm going to reattach this, even though I'll have to take it off again when I reinstall the CRT rather than just keep a bunch of spare parts. I always try to reassemble as much as I can as I'm going while I'm going. Now, you can also get a really good look at this broken bit. So, there's it's right here, a spring that's supposed to loop around on that lucite. And then we'll hook around the CRT. Let's see, one end is here, but not the other side. So if I had the piece, I could attempt to glue it. I don't. It's an awfully big thing, and I assume they chose that material because it can withstand the high voltage. Because remember, the metal CRT, which is energized to 10, 12,000 volts, sits on this, so it needs to be very well insulated from that. I don't know what kind of plastic it is, but I could try to do something, epoxy something on there, I suppose. Anyway, with that out of the way, I can get at everything. I can clean everything, clean up all the controls. I've already started dusting it out a bit, and that's why I really took it out, was trying to install the rebuilt Adaptacap, and it was just getting too hard to fish the screws down in there. This is still in the way, but it's nowhere near as bad as with the CRT in. So I'll do that one, then I'll do that one, and then I'll do that one. The more I work on this chassis, the more familiar I get with it, the more sense it's making. I've traced out the wiring. The more I was encouraged to just keep going with the recap, so I decided to just go through and finish it before powering it up. And there's some other reasons for that too. I've tested some of these caps. They are terrible. These are all rated for 600 volts. They're leaky at 2 or even 100 volts. So out they go. The electrolytics have replaced 2 of them so far. Terrible. This one, the base is bulging and actually smells bad. I don't know what kind of sealant they used on this thing. It looks different than the other caps, maybe because it's rated for 475. It's very, very leaky. And this is, one section of this is the main cap right after the 5U4 rectifier. So I wanted that out. I've also been finding, in general, the power supply circuits have issues. So I'd mentioned earlier that this resistor was open. Some of these other power resistors, which are part of the power supply for different voltages, were way off, so I've been replacing them. The rest of the resistors in general are not bad, but the power supply, maybe because the caps were so leaky, bad things have happened to it. Some of the resistors were about 1/10 of the value they should be. And you see they're used in here in the power supply. So on this rail, we have a filter choke, but on the other two, they're using resistors to form pi filters. These resistors were bad. This is the one that was replaced and they used the wrong value. And this one was way off. As on that 3300, that's the one that was open. So I'm just going through it. Also, some of these caps are 2-3 layers deep. So when you start getting in there, you kind of have to just replace them all while you're at it. Here's where I left off last night. So I had this guy, and behind that this guy, and behind that guy. 3 caps stacked up on top of each other. Now I also took out that cap that looked like a mica capacitor. It is a mica mold. According to the schematic, it should be 0.01, which would be brown, black, orange. I'm having trouble distinguishing those. It all looks brown to me, so I thought I'd put it on my capacitance bridge and test it out. But guess what? At just 100 volts, it's leaky. And it's so bad, I can't measure it. It shows it has a shorted capacitor, so I can't confirm the value, so I'm going to go with a 0.01. Now, why did they use that type? All the rest are bumblebees. It is an original. In the parts list, they call it a molded capacitor. Same as all these. I find it a little hard to believe that Zenith couldn't come up with a 0.01 from their other part sources. But I think it is the only 0.01. The only 0.01 I've seen in here so far, so maybe they just had to go with what they could scrounge. This TV was really ramping up, and I imagine some parts might have been a little harder to get than others. Or they thought that this had some special characteristics, like maybe it was more stable. Obviously, it turned out to be a terrible capacitor. Some other things of note. This guy looks like a ceramic disc capacitor, right? It has 3 leads. You might think, oh, it's just a dual ceramic cap. No, no. It is the vertical integrator. It's that guy. Call it a couplate, sort of. Thick film hybrid. Normally there'd be 3 capacitors and a couple resistors. They put it all inside of this package. Unfortunately, I didn't put the values, but they're kind of standard, so if this is bad for some reason, we could make one from discrete components. There are a few other ceramic discs here and there, though. As near as I get, there's nothing special about them whatsoever. Some of them are just clearly like this guy was on one of the cans. It's just this cap. It's just there for additional power supply filtering for higher frequencies. I don't think it has any special Tempco or anything like that. So, but then again, ceramic disc capacitors are kind of a new thing back in 48, 49. So who knows? Who knows? They're cheaper. They're a hell of a lot cheaper. So I would think they would use these as much as possible, wherever possible. And later down the line with newer sets, they did start using them more and more and more. So maybe they were just starting to experiment with using them. I don't know. And we do have a few true micas here and there. So I just have a few more paper caps to do, maybe half a dozen, and one electrolytic, and then we'll power it up. These power resistors, I finally noticed there was one up here as well, and this one, they both test good. Those are the filament droppers. It's these two guys. So we'll leave them in there for now. Could potentially replace them with capacitive droppers or diode droppers or simply new power resistors. But they test good for now. We'll leave them in for now. I have the chassis flipped right side up now. And see with that CRT removed, we can really see down in here. And, you know, I'm not so sure about this cap being a replacement now because it is Zenith branded. It's dented in on the side. It was crudely mounted, but I couldn't tell from the solder connections if it was original or not. I mean, it may have been replaced with a Zenith part way back when. Maybe it was still under warranty even. I don't know. What I do know is I have the replacement ready to go. Just working on the best way to mount it because there's some other stuff in the way. There's this huge grounding braid from the tuner. Well, with some signals, actually, it's not just braid. It's it's shielding for several wires going up to the tuner. And the AC comes in right here, and they have this loop tack welded on to the chassis. So we have to kind of work our way around that. I think this is basically the only way I can go. If I want to drill a couple holes and mount this securely, is right about like that. So once I get that wired up, I'd like to use a test CRT. So this guy, which will certainly fit in, and same diameter, same base and everything as what had been in there, so that's not an issue. But what is going to be an issue is the high voltage, because the original has that metal CRT cone, so there's this which clipped over the metal lip on the front of it. Well, this has a button connector on the side. So for safety's sake, what I should do if I'm going to be using this for any length of time, and I probably will as I troubleshoot it, is to unsolder this, remove this, put it to the side, and put on a traditional high voltage connector, or possibly replace this entire lead. We'll see how it's connected down there. If that's easy enough to get out, I'll just replace this whole lead. You know, it doesn't look very thick. As far as high voltage wire goes, it's a little skimpy on the insulation side. So, anyways, so we're getting close to powering it up. When I first power it up, I'm going to leave these two tubes out. Those are the rectifier tubes, and turn on, and we should just see everything light up. So there are a few other minor issues that we'll have to contend with once we get this thing powered up, as I've been cleaning it and reviewing it. For example, we don't have shields on these tubes. For sure there should be one over this and one over this, but different style. This was the type that snaps on around the base. This has a piece of wire running up the side, so some type of shield must have been over this, and it would rub against that. I'll have to look for some reference photos and see what kind of shield is supposed to be on that. Be some missing on the main board too. It seems odd that not a single tube has a shield on it in the IF or the tuner. Yeah, it'll work without the shields, but you could certainly pick up noise without them being in place. Well, that holds in there pretty well, just sitting like so. If I was to tip this on its side to work underneath, it's not going to fall out or anything, so that's a good thing. I also went through and I cleaned, lubed up all the controls, and I did clean the tubes, but I haven't tested any of them yet. I'll try powering it up first, and then I'll have to go through and deal with that at some point. Okay, I admit the suspense is getting to me a little bit, and it turns out you can clip this high voltage lead onto the CRT fairly well, so I did not replace the lead. I did install the two rectifier tubes, and I have a high voltage probe handy, and I hooked up a speaker, so I propose we go for it. Yeah, the lighting's not so great. It's because I intentionally have the lighting dim so I can see the tubes glowing and just look for any signs of trouble. So, without further ado, here we go. Turn the volume up all the way. I'm checking the current draw. We're at about an amp. It's shooting up 1¼ amps. Almost 1½ Holy cow. Well, that I wasn't expecting. We have a little shy of 8,000 volts. It's a tad low, but not too bad. I was not expecting to get a raster on the first power up after all that work. That's really cool. It's all kind of weird and off-center and cropped off because, well, two reasons. One, the CRT is not firmly pushed back in the yoke. And two, there's a permanent magnet, focus magnet on this, and these CRTs are still focusing, and that doesn't need that magnet. The magnet being there skews things. Of course, I'm not going to push this up because there is 8,000 volts exposed right there, and I don't want to get shocked. But hey, wow, that is really cool. And my God, the tuner seems to actually be kind of sort of doing something. Okay, signal hooked up to the antenna terminals. I think I'm on the right channel. Alright, let's test some tubes. I'm going to go with my workhorse, the Hickok 600. I can test everything from the 20s up to the Compactron era, so basically it covers a vast majority of the stuff I work on. Only downside, or some may see it as a plus, I'm sure, is that you have to throw a lot of switches to set it up for testing any particular tube type. I also sometimes use a Hickok Cardmatic, which takes punch cards and generally covers all the TV tubes I work on. I have the basic set it came with. It has sockets for earlier tubes, but I've never gotten cards for that. I'm talking because I'm waiting for this thing to heat up. It has two tubes in it, a 5Y3 and a Type 83. You have to let them warm up before you can test the tube. Rather than just testing all the tubes, I will eventually. We know that we have sweep, we have high voltage, we have no reception. So let's start with the tuner and the IF tubes. So let's see, what do we have here? A good old 6AU6. Wow, and it's a WB. I think this is a long life version from 1961, 45th week of 61. So somebody was servicing, working on this set in the 60s. Interesting. So we scroll through the chart for a 6AU6. 6.3 JR 3 5 6 7 2 1176. It's a mutual transconductance tester. Not really all that critical. Well, it's just not that critical for TV tubes generally. If it doesn't have an open filament, it doesn't have any shorts in it, there's a good chance it'll work. But I have it, so that's what I'm using. Also have a Sencor TC162, which is a bit easier to set up, but I had this tester handy, so I thought I'd give it a whirl. Alright. No shorts. And it's very good. Alright, I'll hunt around. I'll probably have a few more 6AU6s. Yep, there's another one. A total of 4. Yep. The one thing this tester can't do, though, is check for leakage or secondary emissions, which the TC162 and the Cardmatic can, but generally not an issue. Certainly wouldn't completely kill reception. So the missing tube shields, would that do it? There's one situation where it might, is if the tube shield over the local oscillator is missing. That will affect the internal capacitance, throw off the frequency a little bit at the higher channels, 7, 8, 9, where you're into 200 plus megahertz. Lower frequencies where we're at, I don't think it'd make that much of a difference. Not enough to cause the problems we're seeing. I suspect we have a very weak tube, or there's something up with the AGC or antenna connection or dirty tuner contacts. Also, when I was first cleaning this set, I took the tuner tubes out. They didn't look right to me. I think they were in the wrong positions, and I looked at the tube chart and put them back in the right positions. The reason I say that is one of these sockets is ceramic, and I'm sure that's for the local oscillator. But maybe I'm wrong. Maybe they should be the way that they were when I first opened up this set. So maybe we just have some wrong tube types in the sockets. If that's all it is, I will be ecstatic, because troubleshooting this set does not look like much fun. Alright, all the 6AU6s are good. Yeah, to thoroughly test tubes, you should let it sit longer and warm up more. It's been my experience with TV tubes, 6AU6s. They're pretty basic tubes. A quick test would weed out any serious issues. We're getting no reception. It's not going to be a slightly weak tube that's completely killing this. It's going to be like a dead tube. So, Alright, I will continue on. Well, all the tubes tested good, so that's no help. So I switched to using my VG91 for a signal source. This is kind of interesting, I thought. As I go between different channels, I'm tuned to channel 2 right now. If I go from 2 to 69, then back to 2, it kind of freaks out. Let's go to channel 4. Nothing there. Oh. They go between 6 and 7, it kind of reacts. So I'm wondering if that could be an AGC issue, so it detects a signal coming in and it thinks it's way too strong and it's killing the gain. That's a possibility. There's also another possibility. This uses a germanium diode for the detector. That could be bad. It's a 1N64, I believe. So I think we should try swapping that out. Although I'm kind of torn. I don't really think that's going to be it though, because it's getting snow, it's getting noise, and it kind of responds to the contrast. I'll put contrast all the way down, it goes kind of gray, but if I put the contrast up higher, it's getting snow, and it reacts when I change the tuner. In other words, it's doing something. It seems like there's no signal getting into the tuner somehow. Okay, I don't know what I just did, but, well, I know what I just did, but I don't know why it's helping. I took the cover off the tuner. I was probing around all the resistors. I found one very crispy looking 1K resistor, but it tested okay. I replaced it anyways. Still no luck. I was playing around with the channel oscillator adjuster, which does work now that I can see everything. I can see it connects to a variable inductor in there. Then I noticed the 6C4 was kind of dim, but it was lit, and I just pulled it out for the heck of it and stuck it back in, and we have sound. And it looks like we may very well have video too, and I just need to adjust the sync. So, dirty socket pins maybe?
Next on H&I, Baywatch, followed by...
Let's see, horizontal, oh my god, we have video. Wow. Oh, I guess the 6C4 socket, that nice porcelain socket, had dirty contacts or something. I mean, it wouldn't be the first time just by poking around and taking tubes in and out of a socket and that a set started working. You know, these things get so crusty over time. The detector diode, I did check it, and it has been replaced, and it does check good. This crispy resistor looked like it had been clipped out of one end and then reattached. So there may have been somebody poking around in here, checking on things. It is quite the contraption. So this is how the fine-tuning works. It is two eccentric bits of metal that rotate around through some sort of coupling system. It is weird. That's why I don't want to go any. I don't want to have to mess with that any more than I already have. I've already gone deeper into it than I ever wanted to. Thank goodness it seems to be working now. Of course, now that I played around with the fine tuning, I screwed things up. So of course I have to reattach that dial string. Huh. So it's the RF amp tube that's actually the sensitive one. Huh, interesting. So I removed the adjustable permanent magnet assembly for the neck of the CRT. That was what was interfering with this test CRT that is self-focusing And I did dig up a couple of tube shields for the tuner, and now it is working much better. Let's zoom in on that.
I have lived with tremendous pain in both of my knees for many years. Getting out of bed was difficult.
Any of you at home really care about your aches and pains, your soreness? Omega is for you. It is derived from the movement muscle, it's waters of New Zealand, and it is full of over a third.
So aside from some minor adjustments,
Fatty acids is not found
I think we got it.
in any other product other than Omega XL, and it has been shown in clinical research.
Trying to get it so that the fine tuning is kind of a sweet spot right in the middle. Wow, this has really good bandwidth. It has a really sharp picture.
Has given me an opportunity to get my life back.
Omega XL is not a pain block. It doesn't come with a prescription card. It's a real shot.
Now, if you recall, the full-size CRT has a metal cone. So what does that mean? That means if I install it and put that clip on it, this entire area will be at the full high voltage potential, which makes it very difficult to work on. And I do kind of wonder, how did servicemen back then, if they didn't have one of these 5AXP4 or a similar test CRT test jig, how did they work on these sets without getting shot? Very cool. Now I do need to go through and test the tubes on this side, the octal tubes. I didn't test these yet. And you may notice the audio is not so clear. Well, this uses the 6B and 6 gated beam detector tube, and those typically have a buzz control. I noticed there are two rheostat type adjustment controls over on this side. I suspect one of them will be a buzz adjustment type control, which will help improve the sound.
Son, that movie is classic. Home and watch movies like that, you would have to go to film acting class. You don't just learn acting by watching movies. You have to practice. I've learned a lot in those classes, Mom. Look, here. Now, you read this and I'll show you exactly what I mean. Now, you be Father Callahan. Go ahead.
So the main thing left to do
This is Father Callahan, children. You haven't got a chance. You're surrounded with
is restring that dial. Aside from testing with the full-size CRT. Very happy that this works without me having to dig any deeper. That tuner it's really a trip. Now the owner of this set, we've been chatting. In a few months he's going to be sending me another porthole set. It's going to be a 16-inch, I do believe. So we're not done with these yet. Plus I have my own, which uses a very similar chassis, maybe the same chassis. 16-inch CRT though, but it has that same deal where the top surface is isolated from the main body, and it is hot. So yeah, the fun is not over with these Zenith porthole sets by any means.